Hi everyone, this video is on factoring quadratics using completing the square. Now, unlike the last video, this one's a little bit tougher problem to do. If you notice, the first thing that I asked you to do on the last video was always to check that a is equal to 1. In this case, a is not equal to 1. So we're going to have to do a couple of extra steps in order to get a equal to 1. The first step that you must do to make a equal to 1, you're going to have to divide all the terms by 4 in order to get a equal to 1. If you notice, 4 divided into 4 turns it into 1, so we end up with x squared minus 1/2 x minus 5/4 equals 0. And just like on the previous video, we're going to go ahead and take the additive inverse of the c, or the constant, which is this term right here, in order to make them go to the other side of the equal sign. So we're going to go ahead and add a 5/4 to both sides of the equal sign, therefore eliminating the 1 on the left side. Now our left side can be cleaned up and look like this: x squared minus 1/2 x, leave a space, 5/4 on the other side. So now the next step, if you remember, we actually went to the side to find what the number was that will help us to figure out what we need to add or subtract in order to complete the square. And if you remember, the equation looked like this, or the formula looked like this: b over 2 to the power of 2. And if you notice, we identify our b to be negative 1/2. So we're going to substitute that number into the place of b. And we're going to get negative 1/2 over 2 to the second power. Now this looks messy, so let's go ahead and clean it up and rewrite it so we can understand it. This actually looks like this: negative 1/2 divided by 2 to the power of 2. Let's continue to clean it up. Negative 1/2 times 1 over 2 to the power of 2. If you notice, we'll get negative 1/4 inside to the power of 2, which at the end we will get 1 over 16. And that's the magic number that's going to help us to complete the square. That's the number we're going to use to add to both sides of our equation. So I'm going to go ahead and add 1/16 to this side, and I'm going to go ahead and add 1/16 to the right side. Now that I've done that, I notice that I look at this and I've created a perfect square that looks like this: x minus 1/4 to the second power. Now on the other side, I'm going to go ahead and get common denominator so I could add those fractions. And I notice that my common denominator is 16. And what I do is I check how many times is 4 going to 16, which is 4 times. 4 times the numerator will give me 20. The second fraction stays the same at 1/16. So then I clean it up some more and I say x minus 1/4 on the left side to the power 2, and on the right side I get 21 over 16. Just like in the prior video, I'm going to take the square root of both sides. And on the left side, the square root and the power of 2 cancel each other out, leaving me with x minus 1/4 equals plus or minus the square root of 21 over 4. I can take the square root of 16 and say it's 4. 21 is not a perfect square, so it's going to remain inside the square root. Alright, from this point on, I know that I need two equations, so I'm going to go ahead and merge out. And my first equation is x minus 1/4 equals plus square root of 21 over 4. And my second equation that I have to solve is x minus 1/4 equals negative square root of 21 over 4. Solving for x, on the first equation, I am going to add a positive 1/4 to both sides, so I can get x by itself. Leaving x by itself, I get x is equal to 1/4 plus the square root of 21 over 4. I will do the same thing to my second one, adding 1/4 to both sides. And then I would get x is equal to 1/4 minus the square root of 21 over 4. Now, in order to check this, we would need calculators in order to figure these roots out and the specific decimal points that we will get. So let's go ahead and look at decimals to check our work. Now what I've done is I've actually plugged in 4x squared minus 2x minus 5, which is the quadratic we started with. And then what I did is I took and I found the roots. And then what I did, in order not to use a calculator and to show you the connection, is that I substituted or plugged in the actual answers, changing 1/4 to 0.25, so don't get confused. And then what happened is, if you notice, the values of it match the roots. And that's how you use completing the square.